In Lecture 6D, we're going to talk about data locality, specifically how data locality and networks work together to help support data-intensive scientific computing. We'll talk about local data on your desktop or laptop, remote data that you access over the network, and cached data that moves data between remote systems and your local system. First, let's talk about local data. This is data that would be found on your laptop, desktop, or personal device that you own. A laptop moves data between devices on that laptop via a bus. This example would be moving data on and off the laptop via a USB drive, or just simply typing in data via a keyboard or the mouse. All of that data flows through a bus on your system and shares data between all the devices that are connected to that system. This bus is local and it's fast, faster than a network and typically more reliable than an exterior network. So why use the network at all? Well, there's limitations of local data on your device. So first, you can only connect so many data storage devices. You might be able to daisy chain those, but the actual direct connections to that bus are limited. So the specific interfaces, such as eSATA, PCIe, or other ways that you might connect to it, also don't provide all of the connectivity that you're used to with a network that uses TCP/IP. The system is also separate in terms of your ownership and admin. So you have access to all of your data, but how do you share that data with others? Do you give them access to your laptop? How do they get that data without going over the network somehow for sharing purposes? So sharing becomes very complicated for that local data without having network connectivity and without having advanced layers of authentication. Also, you may have limited processing power. What does that mean? Well, maybe you want to use many cores and your laptop only has 4. So the data is local to your laptop. Maybe it's not huge. Maybe you have 50 gigabytes of data, but you want to do something that requires a significant amount of processing time, and it takes a week to process on that 50 gigabytes of data. Well, unfortunately, now you've just lost access to your laptop for a week as it's trying to churn through that. Maybe it could be faster if you had a more powerful system, but again, you have what you have on your local laptop or your desktop in terms of cores, in terms of RAM. And so you may not be able to scale if you want to keep everything local. And then finally, what about disaster protection? You've got this local data and it's fast and you can control it. These are all positives. But what if that laptop or desktop fails? Do you have redundancy? Do you have some sort of disaster preparedness such that if the laptop fails, have you lost all of that data? Do you have a copy somewhere else? Do you have a backup in any other sort of way for the hardware on that system in case it's damaged or stolen? So remote data starts to answer some of those limitations we talked about, albeit local data was fast and local data was convenient. We had some scale limitations there. Now, when we go to remote data, we're also going to have to add some complexity. It's not quite as simple as we remotely just attach a disk drive as we might think of it. There's typically going to be other levels of complexity because that data that's remote is going to be on a disk or some sort of storage medium that's going to go through a server so that we can set up connectivity between that remote resource and our local resource. We're also going to have to keep track of copies and concurrency of that. What if you're accessing the data from multiple sites? Think about it. If you're logging in and you want to touch a file and you accidentally leave that file open on your laptop, that remote file, and then you go home and you want to do some more work on that file, how do we keep concurrent copies or currency between those particular remote access sites? We also have to learn potentially new tools to transfer the data. Data that may have been local, that you may have been able to access with a particular application, may not be accessible without copying data over, moving data around, or using new applications. You may have multiple authentication accounts. So prior to things living all locally and you could just log on to your laptop, you may now have to have an authentication account for data that's at a different institution or data that's in a different commercial platform such as Google Drive or Box. You're going to have performance bottlenecks that you didn't think about necessarily before. When it was on your laptop on an SSD or a local drive, you could have an expectation for how quickly you could get access to a file. Now that it's remote, what if the remote side is down? What if the remote side is slow? And what if the network in between is having any particular sorts of issues? We also have to understand that security may not be applied uniformly, whether that be commercial companies and Google Drive having specific authentication requirements, or any other university that has authentication and login requirements, but may also limit particular application ports and other things as we talked about in terms of network security and firewalls. It's also important that think about quotas and costs differing. Um, on the positive side, you may only be able to have a terabyte or so on your laptop, and now you might have a quota on a large distributed storage device that might be 10 terabytes or 100 terabytes. But those costs differ in terms of what a terabyte might cost for a hard drive you would put in your laptop and a terabyte that you would use on a distributed system. Finally, we also need to talk about the complexity of troubleshooting. Now it's not just your laptop that you're used to maybe working with. Now you've got data remotely stored that you don't control, that may or may not be well documented. Who do you contact? Who do you talk with when getting access to that data either is completely blocked or is slower than you expected? Finally, I want to talk a little bit about cache data. Cache data kind of tries to do the best of both worlds between data local and data remote. It would be great if that remote data provide disaster preparedness and huge capacity, and at the same time we could have the portions of that data we need locally for performance and for access. The concept of caching is common in computer systems and memory hierarchies, from moving data into RAM to disk to other distributed file systems. But you can think of caching also broadly in many engineered systems, such as supply logistics. If you've got a store and you want to keep everything on the shelf, just the right amount of product on a shelf for consumers that are going to purchase it. You don't want 10 times more than the consumers are going to purchase. You have then, you need a lot more space within your store, and you've got to move around a lot of data, or in this particular product, that's not being utilized. So back to the computer science focus, let's talk about that, data and how we would do caching. Typically how it's done is if you have a remote piece of data that's regularly used, you want to have a local copy. And it's fairly easy to automate that such that once a file has been opened, a copy is brought over. Now synchronizing that gets more complicated, but in general, you want to be able to have a file that you're using regularly be moved locally. And then if you stop using that file and it becomes cold, you want that cold file to either be deleted if it's a copy or move back to the remote file system so that we can replace that with the hot files or the files that you're most interested in currently using. A lot of systems are doing this for you automatically. The operating system, RAM management, hybrid disk drives, RAID controllers, and a number of file systems will try to cache data as locally as possible to the system that you're working on while it's still keeping larger remote copies further over the network. And last, we want to mention, if you start using a file and it becomes hot, the system can dynamically figure that out. But what if you want to have a system immediately ready for you? You might want to let the system know beforehand that you're going to be accessing that. And simple ways of doing that are examples that you might think about are Box and Google Drive Sync, where you can designate which directories or which files you want to be cached locally on your laptop so you can work with them on a regular basis, and which directories you do not want to have cached on your laptop that can just exist remotely and you can get access to those as need be.